that worked extremely well for about 2.5 to 3 years. One day, I came in for this class, and I put the Klingon sheet up, and I said, what's the average of the Klingon numbers on the screen? Everyone's eyes glazed over, and all that stuff. Little light bulbs came on. You see people doing this. Finally, dead center, back of the room, guy's hand goes up. And I'm like, yes? 7.5. And I'm like, what? 7.5. I'm like, how do you know? He's like, I added them up and divided by however many numbers were up there. I'm like, you can read this? Yep. Seriously. So I went like this. I got like it was contaminated. I picked it up and I threw it out. That to me was too bizarre. And that he had way too much time on his hands, right? So it's interesting. I thought, sometimes when, we call these things giant stories. A story that has existed for like how long I've been teaching tends to get inflated a little bit, exaggerated and so on. So I recently found my 3-ring binder with all my overheads. So I thought, I wonder if I made that whole thing up about, I know I picked it up like this, like it was disgusting, but I didn't really truly remember if I threw it out or not. So I opened up the notebook and I'm flipping through and I found the white sheet, because you have the overhead and the sheet that it's copied off of was in there, but the overhead wasn't. So yeah, I truly threw it out. So think about it this way. It is possible to get an average if you don't have numbers. You just simply use the mode. The problem with the mode is this. It's possible to have no mode. What if every single person in this room has a different shirt color on? And then I say, what's the average shirt color? And we use the mode. There's no mode because nothing repeats itself. It's also possible to have more than one mode, bimodal. So what if 5 people have red shirts, 5 people have blue shirts, and everyone else has a different color? Then the mode is red and blue. What if we have 5 red, 5 blue, and 5 green, and everyone else has a different color? Now we have multimodal. We have 3 modes, red, blue, and green, and so on, and so on, and so on. So if you have 10,000 numbers, and they're all fairly tightly together, you could have 1,000 modes, which is kind of worthless, right? So that's why love-hate sort of relationship with me in the mode. And how do the procedure for this? We arrange all the scores from the smallest to the largest. We underline all groups of matching scores. And number 3, if there are no matching scores, there's no mode. If one group of scores is larger than all the other groups, that's the mode. If we have 2 groups that have the same number of scores in it, then there's 2 modes, and so on and so on and so on. So here we go. Let's look at this. I color-coded these. I'm going to really zoom in quite a bit. All right, so this is the front foot length, I believe. So if you look here, we have 1, 2.2. We have 2, 2.25s. We have 2, 2.3s. We have 3, 2.35s, and we have 2, 2.4s. This is the mode. Now this one, we have 2 1.95s, 1, 2, 3, 4 2s, 1, 2, 3, 4 2.05s. So our mode is both 2 and 2.05. All right, next. The next is the mid-range. By the way, this is a red fox. If you haven't seen one, there's some little cute pictures of it that I found. All right. What just happened? All right. So now we're going to talk about the mid-range. The mid-range passes the Perkins technique test. And in that, we can do this with probably by hand or on a Perkins napkin. All we do to find the mid-range is we take the highest score and the lowest score, add them together, and divide by 2. Here's the problem. Let's say this represents the income of professional golfers. All right? All of them are on this table. lot of people do professional golf salaries for their final projects in my basic Stat 1 class. So let's say these are all the golfers. And let's go back in time to when Tiger Woods was on the top of his game and was making gazillion dollars. So here are all the golfers' salaries, and Tiger Woods is over by that wall somewhere, right? So where's the center of the blob? Well, this is the blob. There's one score over there. But this is the blob, basically. So I would say the center is right here, and that's just some freak score. However, the mid-range is going to take the lowest, which is right here, and add it to Tiger Woods' score, and then divide by 2. It's going to say the center of the blob is over here. It's not. So sometimes the mid-range doesn't give us accurate scores. Now, if the data is pretty symmetrical without outliers, then the mid-range will give us a pretty good indication where the center is. Which for me, when I was dealing with Olympic athletes, worked most of the time, because you don't usually get, most of the Olympic athletes are fairly evenly matched within the same country. Right? Very rarely do you get one athlete that just dwarfs all the rest of the athletes from the same country. You might have one country that dominates another country, but I'm talking about within the same country. So when I was dealing with the data for that, I could easily do the mid-range and get an idea of roughly where the center was. All right. So we take the highest, add it to the lowest, divide by 2. Actually, let me show you something before we do the example. So this is a royalty-free photo that said that this was a fox track. Now let's look at it and see if they know what they're talking about. Well, this is a dog because you can see the nail marks. However, notice that the back paw is not directly in the front paw. This is indirectly registering. So unless this animal is slipping, which it's not because you can tell from the pressure releases, this is not a fox. Whatever type of dog it is a male dog because see the back feet are closer together than the front feet. Also, there are these things, we're going to learn more about this throughout the semester. We have these things called pressure releases. There's over 1,200 pressure releases that you can see in a track to know all sorts of things about the animal. If you look, see how this is raised up right here? More so than this side. So this side is higher up than this side. That's called a ridge, which means that this animal is turning this direction, to the right. Not much. If it's walking at that remote at 10 feet away, it is turning from that remote to about here. So it's just making a slight adjustment in its turn. So you can tell all that from that track, but one thing's for sure, it's definitely not a fox. All right. Below are measurements gathered from 10 Red Fox tracks. We want to find the mid-range of the front foot length and the mid-range of the front foot width. So we take the smallest, the minimum value of the front foot length, and we add it to the maximum value. So 2.2 plus 2.4, and we divide by 2. So we get 2.3. That's the mid-range. The width, we take the smallest width, which is 1.95, and the largest width, which is 2.05. Add them together, divide by 2. We get a mid-range of 2. Very simple way, very quick way of finding out where the center is. So let's say I'm in that Perkins restaurant, and my boss comes in, and he has 1,000 pieces of data. Even if I have a calculator, do you really think I'm going to sit there and go like this and add them all up and divide by 1,000 to figure out where the center is? No, but I got to deal with it somehow, so I find the mid-range. I just find the largest value and the smallest value, add them together, divide by 2. Pretty simple. In today's age with computers, and after this class, you guys are going to do everything on a computer. Even for the final project, you're going to do everything on the computer. You're never going to do any of this by hand. So you just push a button, it's going to give you everything you need. But it is a simple way of figuring out where the center is. All right. So, if I have a distribution, we're going to talk a lot about distributions this semester. So let's say I have a collection of data, and if I graph it, it looks like this. It looks like a bell. It doesn't even have to look like a bell, but in this case, it's symmetrical, which means if I take the center of this thing and I flip this side over to this side, it's going to be the same. It's a mirror image. If that's the case, and there's only one mode, then the mean, the median, the mode, and the mid-range are all going to be the same, or really close to the same. What happened to the chair? All right. However, if the data is not symmetrical, and we call these tails. If one of the tails is longer than the other tail, so let's look at the next one, then what happens is that tail that's longer is going to start pulling some of these averages. So let's say this controller here is the median, the chair is the mean, and I'm the mid-range. So let's say at the beginning of Tiger Woods' career, when he's still in this blog, then all of a sudden he starts doing well and his salary starts going that way. That's going to pull me as the mid-range with him, which then is going to start to pull the mean, like this. The mid-range is really going to start moving up. The mean's going to move just a little bit. Now in this case, this is more than just one person or one score. This is quite a few scores. So as this gets pulled out, it's really going to pull the mid-range, because the mid-range is halfway between this end and this end. The mean is going to get pulled out, and the median, it might not even move at all. It's very not suggestible to these extreme scores really that much, unless quite a few of them move out. So this is how it gets affected. This one gets pulled first, then this one gets pulled, then this one, the mode's just going to stay where it is. And the further out this tail goes, the further that mid-range and the mean get pulled out. We're going to talk about this in a couple classes from now when we talk about skewness. And so you don't have to really worry about this at this point. But if the mean is greater than the median, that's a strong indication that my extreme values are over on this side. So in other words, the high end. If my mean is less than my median, that's a good indication that the extreme values are down here in the low end.